Well, hey everybody, we are moving down the line again with our solving equations. This time we are transitioning to the ones that start to get a little bit more difficult. These are multiple steps that are involved, and sometimes we have to really pay attention because the variables might not always be on the same side of the equal sign. This comes from Chapter 2, Section 3, and Chapter 2, Section 4 of our Pearson textbook. So remember, as we're going along, we need to start to remember to please justify your steps. They are going to ask us problems on our EOC test that have an entire problem filled out. All we have to do is say what gave them the right to justify each one of the steps that they did. And of course, if you're doing your homework, using different colors is always useful. It helps us to organize things and keep things straight. So let's look at this first one. Again, sometimes directions are super simple. All they say is solve. So this has a lot of pieces to it. What do we start? Where do we start? What do we do first? Those are all the important questions we should be asking ourselves. And hopefully you notice the parentheses. And there's a 3 right outside. This is telling us that we need to distribute this to each piece inside of that parenthesis. So we have 3 times a negative 4 is a negative 12x. 3 times negative 1 is a negative 3. Everything else is going to carry down, and we have finished our first step. Notice, what was the very first thing we did? We combined like terms, and that was it. So if we're we distributed. I'm going to just abbreviate this. And next we're going to do is we are going to combine like terms. So again, switch colors. You have the ability to do that. Our next step is going to be combining like terms. We have to figure out, well, what are we going to combine? Well, look here. We have x's here. We have x's here. And then we have some nice constants over here. That's what we're going to be combining. So the yellows, let's put them together. We have a negative 14x. And we have a negative 3 and a positive 4 that gives us plus 1. All right, now as we start to go down and look at this and be very careful at it, we are looking at this and we're pretty much almost done. Always double check your work. Make sure that when you're doing these, you're being careful with your signs. Okay, a negative and a negative is a bigger negative. A negative and a positive gives us a positive result. All right, we've finished the combining like terms step. Now we need to switch colors one more time. Let's go to green. So now we look at this and we have to draw our scales. As we sit through here, this is our variable we're trying to solve for. So we box it in, which means this is what's left over. We have to subtract 1. Gives us 42. These cancel, and we're left with a minus 14x. Great. And what did we do here? We did the addition, subtraction property of equality. And if we look, our x is still not by itself, so we have to then do another step. Notice that negative 14 is being multiplied, so its reciprocal property is to divide. These will cancel and leave us with just an x. And here we go, 42 divided by negative 14. 14 is 28. 42, and so you get what, a negative 3. X equals negative 3. We could check this, guys. You have the ability to take this number in, plug it in, check. You'll get your answer, 43. Here's an interesting one. Take a look. We're going to do our traditional method where we box our variables, right? Notice what's weird about this one. We have variables on both sides of our equation. Both sides. So now what we have to do is we need to make sure we're trying to gather all of our variables need to be on one side of the equation in order to solve it. So if we look here, we've got positive 7 on one side and negative 3 on the other side. We can use the rules of math, our properties, the addition, subtraction property of equality. If we don't want something on one side, we're allowed to move it. We want to make it go to this side, so we can subtract 3. We can subtract 3x. These will cancel and leave us with a minus 23. And then the minus 7 comes down. And 7 minus 3 is a 4x. Great. Switch colors because we are moving to another step. Now we notice if we're going to box our variable again. So, I mean, this now looks exactly like what we have been doing. We have to use the addition subtraction property of equality again. We need to move this negative 7. So to move it, we have to add 7. So what are we going to end up with on this side? We have what, 3, 4, being negative 16 on this side. These cancel. Now we can bring the 4x down. And we are almost done, but not quite. One more step to go. Yeah, I told you, these feel like you do a lot more steps than you normally do. But that is what happens as we start to get in algebra. Our problems become slightly more complex, but following our rules gets us to where we need to go. Now, if we look at this, you have a 4 times x. We need to get this x by itself. So undo multiplication, we have to divide. This is the multiplication division property of equality. And divide by 4. And divide by 4. These cancel and leave us with just x. Negative divided by a positive will give us a negative answer, and 16 divided by 4 is 4. Go ahead, take that 4, plug it in over here. You should end up equaling the same thing on each side. What is it? 7 times 7 is 28. 28 minus 7 is 21. Then you do the same. Negative. Wait, I did that wrong. So negative 28 minus 7. This side gives us a negative 35. And you're taking a negative 4 over here. So you're doing negative 4 times 3 is a negative 12 minus 23. So 3 and 2 is 5. 2 and 1 is 3, and it's negative. Notice how they equal each other. Therefore, we have the same answer. We've checked our work. Sometimes odd things happen when we go to solve. Okay, we get either a fault statement or an identity. An identity is where we have all of the answers are going to be the same, and the fault statements is where we have none of the answers that are going to be the same. So we have to be careful about that. So basically, we get a statement that's not true or a statement that equals each other. In any case, what's really happening is you notice that the variables cancel each other out. So you have to be careful. It's not always evident as we first start to look at these, but we have to just be careful. As we look at this, look, we notice here we're going to have, distribution is going on. So we have to be careful, right? There's a distribution on this side of the equal sign. We have to distribute on this side of the equal sign. 8 times 2 is a 16x. 8 times negative 4 is a minus 32. Now we do this one. We have not a negative. A negative times a negative becomes a positive. Watch out for those subtraction or those minus signs. They will get us positive 16x. And negative 4 times a positive 8 gives us a minus or negative 32. Here is a key or a trick with this one, guys. Take a look. Notice that we have the exact same thing on both sides. This is key in figuring out this particular type of problem, all right? I'll show you what happens. So we're going to just go through and keep going like as if we didn't notice this fact. Okay, we didn't notice that we have the exact same thing happening on both sides of the equal sign. So we keep solving as we normally do. Keep solving as we normally do. All right, and here we go. So this is just variables on both sides. I need to move this variable to this side. So the addition subtraction property of equality says I can move it provided I perform the reciprocal operation. I'm going to subtract it from this side. These cancel and these cancel. I'm left with a negative 32 equals. Notice what happened here, guys. We actually had something very interesting happen. Because we have the exact same amount of x's and we have the exact same amount of constants on both sides. What happens is that they end up completely canceling out. So when we do our first step, we get this something weird here. But look what we have. It says negative 32 equals negative 32. That is a true statement. Negative 32 does equal 32. Say if you said, oh, well, you know, I don't trust, I'm going to just keep using. So I'm going to add. I'm going to keep doing your rules. So you're going to add 32 to both sides. Okay, add 32 to both sides. 0 equals 0. Because these cancel. This is still a true statement. This, guys, is called an identity. So this is an identity. What it means, an identity, means that anything you plug into this for x will make it a true statement. Okay, any number you plug in for x will make this a true statement. Plug in 0. Well, this goes away and that goes away, and you have negative 32 equals negative 32. Plug in 1. So 16 minus 32 equals 16 minus 32. Yes, that's true. Plug in 1,000. 1600 minus 32 equals 1600 minus 32. Anything, any number that you plug in will make this true. So all real numbers is a solution for this. Any number you can think of that you want to plug in for x or want to give that value for x will make that true. That's what makes this particular problem very, very interesting. And again, you must, in order to notice it and see it, you will notice that both sides of the equation have the exact same amount of x's. the exact same amount of constants. And identity happens sometimes when we have variables on both sides. Let's look at this last equation. Ooh, this one looks interesting. It's big. Look, we have distribution going on here. 21x plus 12. More distribution.